Let's talk about something truly mind-bending. Imagine an object so dense, so incredibly powerful, that its gravity traps absolutely everything. And I mean everything, not even light, the fastest thing in the entire universe, can escape. That right there is a black hole.
Think about what that means. Once you cross its boundary, that's it. It's game over. You can't send a signal out, you can't see a reflection of yourself, there is absolutely no turning back. You're completely and utterly cut off from the rest of the universe forever.
And that's what makes them so captivating, right? Black holes aren't just things floating in space, they're places. Places where our fundamental understanding of physics, the rules of space, time, reality itself, it all starts to unravel. The rulebook just gets thrown out the window.
So where do these cosmic monsters even come from? Well, every single black hole we know of starts its life with one of the most violent and spectacular events in the entire cosmos, the death of a truly massive star.
See, for millions, sometimes billions of years, a giant star is living in this state of perfect tension. It's like a constant cosmic tug of war. On one side, you have gravity, relentlessly trying to crush the star inward. And on the other, you have the insane power of nuclear fusion at its core, pushing outward and keeping the star stable and shining.
But that balance can't last forever. Eventually, that star starts to run out of fuel. The outward push from fusion gets weaker and weaker, and in an instant, gravity wins. And it wins in a big way. The star collapses, triggering a supernova explosion that can outshine entire galaxies. But if the core that's left behind is massive enough, well, nothing can stop the crush. It collapses forever, creating a black hole.
So a star dies and collapses. But a black hole isn't just a super dense ball of stuff. It has this one feature that has captured our imaginations for decades, an invisible boundary with a pretty famous name.
We're talking about the event horizon. Now, this isn't a physical wall you could touch, it's weirder than that. It's a threshold in space-time itself. The moment you cross it, you can't escape. Not because you aren't fast enough, but because space itself is collapsing, dragging you in faster than the speed of light. Every possible path just leads one way, inward.
Here's a great way to think about it. Imagine space-time is a river. Far away from a waterfall, you can swim against the current, no problem. But as you drift closer, the current gets stronger. The event horizon is that point where the water is flowing faster than anyone. Even the greatest swimmer in the world could possibly swim. Escape becomes physically impossible.
Okay, and here is where things get really, really bizarre. Thanks to Einstein's theory of relativity, we know that extreme gravity messes with time. So, if you were watching your friend fall into a black hole from a safe distance, you'd see them seem to slow down, getting redder, dimmer, until they appear to be frozen at the edge forever. But for them, they wouldn't notice a thing. From their perspective, time would feel completely normal as they sail right past that event horizon.
So, what happens after they cross that point of no return? What does that journey to the center of a black hole actually feel like? Well, I'll be honest, it's not pleasant.
Physicists have this wonderfully grim but very accurate term for it: spaghettification. Yeah, the gravitational pull on your feet would be so much stronger than the pull on your head that you'd literally be stretched longer and longer into a thin stream of atoms. A truly bizarre and frankly terrifying way to go. And that stream of atoms, it's all heading for one place, the center, known as the singularity. This is the ultimate unknown, a point where all that mass is crushed into an infinitely small, infinitely dense point. Our equations, our entire understanding of physics, they don't just get fuzzy here, they completely break down. They give us answers like infinity, which is really just math's way of throwing its hands up and saying, I have no idea what's going on here. And this breakdown leads us to one of the biggest, most profound, unsolved problems in all of physics. It's a fundamental conflict between the two pillars of how we understand the universe, and black holes are smack dab in the middle of it all.
For a long, long time, we figured whatever falls into a black hole is just gone forever. But then, the brilliant Stephen Hawking came along and discovered that because of some really weird quantum effects at the very edge of the event horizon, black holes aren't completely black. They leak a tiny, tiny amount of energy. We now call it Hawking radiation. And over unimaginable timescales, they can actually evaporate and disappear completely.
And this created a massive, massive paradox. If a black hole can just disappear, what happens to all the information about what fell into it? See, general relativity, our theory of gravity, says that information is just lost forever.
But quantum mechanics, our theory of the very small, has a core, unbreakable rule. Information can never be truly destroyed. The universe has a memory. So, which one is wrong? They can't both be right.
Now, to solve this, physicists have come up with some truly wild ideas. I mean, what if the information isn't lost, but it's sort of encoded on the surface of the event horizon, like a cosmic hologram? Or what if black holes are actually gateways, wormholes, connecting to other universes? These aren't just late-night sci-fi ideas. They are serious proposals to solve a very, very real problem.
For decades, all of this was just theory, a battle fought with chalk on blackboards. But then, something absolutely incredible happened. We went from just debating their existence to actually seeing one.
The year was 2019. After years and years of work, coordinating telescopes all across the globe to create one single Earth-sized virtual observatory, humanity was about to see the impossible.
Using what's called the Event Horizon Telescope, a global team of scientists did something straight out of science fiction. For the very first time in human history, they captured an actual image of a black hole silhouette.
And this wasn't some nearby neighbor. The black hole they photographed is at the center of a galaxy called M87, and it is a staggering 55 million light-years away from us. I mean, just try to wrap your head around that distance. The scale of this achievement is just mind-boggling.
And there it was. Now, you're not seeing the black hole itself because you can't, but what you are seeing is its shadow, cast against this glowing, superheated gas that's swirling around it. That dark circle, right in the middle, that's it. That's the edge of the event horizon, the point of no return made visible for all to see.
This one image did so much more than just prove that black holes are real. It confirmed that these supermassive black holes are at the heart of most galaxies, including our own Milky Way. And it totally shifted our perspective. They aren't just cosmic vacuum cleaners, they're cosmic architects, shaping the way entire galaxies evolve.
But even with this breathtaking image, the deepest mysteries are still there. What really happens inside? And maybe the biggest question of all, could black holes be the very place where general relativity and quantum mechanics finally meet? Could they hold the key to a unified theory of everything?
You see, black holes are nature's ultimate laboratories. They push physics to its absolute limit. They represent the point where our current theories fail, and that's exactly where new discoveries are always waiting to be found. Solving their mysteries, well, it might just tell us what the universe is truly made of.